Okay, it is that time. So I wanted to start today by going over the items on page 238 in our packet that we looked at last week. And this is our sills, girders, plates, joists, and bridging. So problem A on 238 looks something like this. Obviously not drawn to scale real well here. But this is the only one that actually gave us the location of the beams. Well, they all gave us the location of the beams, but gave us the exact location of the beams. On the other ones, I told you to assume they were in the center of the longest span. But this one here just flat out gave us that the only beam is right there. So the length of that beam, there are three 18-foot pieces for that beam. So whether we're using 2x10, 2x12, whatever we're using for that beam, there's three 18-foot pieces. Now there is a post given in the middle of that beam, but I would not do any splicing there. Remember we had said we can assume we can use material up to 20 feet long. Forgot to mention the sills here. So whether we're using 2x6 or 2x8 treated for sills, our sills are just the perimeter. What is the perimeter of this? 30 by 46. Looks like that's 152 feet of sill material. For our joists. We have different lengths. First of all, right here we have 10-foot lengths right here. I did not tell you whether to assume you had end joists or not. So here we're going to go ahead and just assume we are using regular joists for the end joists. So that's this here. This is just going to be our regular joists here. The only rim joists we're going to use are at the end of the run. So in those locations will be the rim joists. So for our joists, we got 10 footers. To figure out how many 10 footers we need for our joists, we're going to assume they are spaced 16 inches apart. So the number of joists needed for the 10 footers, 12 over 16. The run is 18 feet, so times 18. And yes, we are going to assume we need one on each end. So that's going to be a +1. So 12 over 16. Twelve divided by 16 times 18 gives us 13.5. We're going to round that up. So it's 14 plus 1, which is 15. So we need 15 of the 10 footers. Here we have a span of 20 feet. Remember we said we could assume we can use up to 20-foot material, so there's no need to break that up. We can span that. The run here is this dimension, which is 46 feet. That's just the 18 plus 28 gives 46. So for our 20-foot joists, our number of joists required is 12 over our on-center spacing. Again, we're assuming we're spacing them 16 inches. times 46. Again, we're going to assume we need them at both ends. That means it's going to be a plus 1. 12 divided by 16 times 46. That's 34.5, so we're going to have to round that up. 35 plus 1 gives us 36. So we need 36 20-foot joists as well. And then the final thing I'd ask you to find is bridging. We need bridging material on any joist that is longer than 10 feet. So that means we do not need bridging here since those joists are exactly 10 feet. We only need bridging over here. One row of bridging down the middle. If it was more than 20 feet, we would have needed a second row of bridging, but we're not using any joists that are more than 20 feet. So we have a run of 48 feet. The amount of bridging needed is the run times 3. So 48 times 3.
Recording is on.
Oops, what does that come out to be? 140. I believe it is. So we need 144 feet. And that's 1/3 bridging material. So we need 144 feet of bridging. Now, one thing we did not discuss last week that I'm going to put in here now, it's not something you are required to do, but that is floor sheeting. Floor sheeting is just the area divided by 32 square feet per sheet. A sheet is 4x8, and then round up. So the area of this floor up here, we have this section that is 20 feet by 46 feet, which will be 920 square feet. And then this section here, I'll call that section 2. It's 10 by 18 feet. 180 square feet, giving us a total floor area there of 1,100 square feet. So the number of sheets of sheeting is 1,100 square feet of floor area divided by 32 square feet per sheet, giving us 34.375, which is going to round up to 35 sheets. Now, in reality, it might take slightly more than 35 sheets. This is just an estimate. If I were actually estimating this if I were actually bidding this or purchasing materials, I would modularize any dimensions. Now, modularize, when it depends on what you're using, like if you're using concrete block, modular means 16 inches because that's the size of your block. When you're using floor sheeting, 4 foot by 8 foot is modularized. So the 20 here, now this is not something you need in your notes. This is extra. But for modular, the 20 foot here is modular because most likely going to be running my sheets this way. That would be exactly 5 sheets wide across there. The 28 here is modular. Well, sort of. It's divisible by 4. And if it's divisible by 4, you can always cut off a sheet If you have 4 feet left over, you can always cut it off and use it to start the next row so you can stagger your sheets. Here, unfortunately, the 46 feet is not modular. It's not divisible by 4. And for our floor sheeting, you need it to be divisible by 4 for it to be modular. So if I were actually bidding this on a job, I would add 2 feet on that end to make this modular. Like I said, the 28 is already modular, the 18 is not. So adding that 2 feet here makes this 48 feet, which is modular, makes this 20 feet, which is modular. And again, when it comes to floor sheeting or any OSB sheeting, modular means 4 foot increments. The reason for the 4 foot increments is because if your studs or your joists are 16 inches apart, it's at 4 feet that you end up back on another stud or joist. Now going out this way, this dimension is 10 feet. That's not modular. I would sheet straight across here, but then sheeting here, you'd end up sticking across 2 feet here. And this that gets cut off here is waste. On a wall, it would not be waste. On a wall, you could reuse those pieces. But on a floor, since you're probably using tongue and groove, 4 by 8 sheets of tongue and groove, you can't, what you cut off there cannot be reused because there's no missing the tongue or the groove. So I would add 2 feet in that direction as well, making this now 32 feet and this now 12 feet. So that is the area that I would use for estimating my floor sheeting. Now for this class, we don't have to do that stuff. For this class, we're just going to take the regular area of the floor and divide it by 32 and round it up. A lot of people, what they do is that's exactly what they do is they just use that method. They take the floor area, round it up, and then they just add a percentage for waste onto it. Typically anywhere from 10 to 20%, depending on what they think the shape of the house is. This house is not modular with its dimensions, so I would probably add 15 or 20% onto it instead of just 10. Like I said, for our purposes, we're just doing the area divided by 32 square feet per sheet. But I just wanted to show you that there is more to it than that, but we're just not going to go into it. Any questions on part A there? Finding the beams, sills, joists, and bridging for part A? I'm going to do part B. So we have 32 feet here, 18 feet, 18 feet, and 20 feet. We're given across here, this is 26 feet, and this down here is 30 feet. So we're assuming our beam is at the center of the longest span. So it's going to be at the center of the 32-foot span. So this will be 16 feet here and here. So if we look at what is drawn in there for posts, it sure appears that they're putting those at 8 feet. Our total here is 56 feet. And they have 7 gaps, so our posts are 8 feet apart. So as I'm doing my beam build up, my first beam would be 16 foot to get to that second post. Next would be 16 foot to get to the fourth post. Another 16 foot to get to that post, and finally 8 feet. So that'd be 3 16-footers and 1 8-footer for that ply of the beam. Now my second ply would just go in reverse. I would do my 16-footers here and my 8-footer at the other end. And my third ply is going to be identical to the first ply. So all three plies are going to use the same material, just starting from opposite ends. So for my beam material here, I have 3 plies that are each that, so it's going to be 9 16-footers and 3 8-foot pieces for beams. For sills, remember sills is just the perimeter. So we've got what, 32, 56, 30, 20. This here ends up being 4 feet. 4, 18. This is 6 feet. 6 and another 18. Oh, so what do we have there? 112, 122, 154, 184. It looks like 184 feet of sill material. For joists here, we need quite a few. I am going to start with the short pieces starting down here. The reason for that is because 20 is a modular dimension. It's on 4 feet increments. So that means that a joist, I'm going to actually end up with a joist. If I assume I need them on the end, I'm going to end up with one here, and there will be one at that 4-foot spot. Now, actually, it won't be exactly on. It'll be 3/4 of an inch off. But we are allowed to move a joist. A floor joist can be moved off of its on-center spacing up to half of its thickness. So if these are 1.5 inch 2x10s, 2x12s, or whatever, or even if they're eye joists, we can move them 3/4 of an inch off. So that's okay. We can be off by 3/4 of an inch. So the length there, this is 16 feet. That would make this 14 feet. So these are 14-foot joists. The number of joists needed there, assuming a 16-inch space, so it's 12 over 16, times a run of 20. And we need one at the beginning and one at the end, so it's going to be a +1. So 12, come on now, back. 12 over 16 times 20 is 15, +1 is 16. So we need 16 of the 14-foot joists. Next in here, this section is going to be 10-foot joists. We do not need one at the beginning here because it's not going to come out exactly on. We don't need one at the beginning there because we already have one from the end of the 14-footers. That last 14-footer is there. So I don't need one there. At the end down here, it's not going to come out exactly on that wall, so I don't need an extra one at the end. I'm just going to calculate my number of joists, and however many I get, that's where I'm going to stop. I will still round up when I get a decimal, though. So my number of joists there, 12 over 16 times 18. I will still round up for a decimal, but I'm going to subtract one because I don't need one at the beginning or at the end. So 12 over 16 times 18 is 13.5. We round that up to 14 and we subtract 1, gives us 13. So we need 13 10-foot joists. Now, The 16-foot joists for this section here are tricky. This is 18 and 18 does add up to 36 feet. So our joists will come out just fine as far as spacing. We need one on this end. We will not need one on this end because it should hit that 12-footer. We are going to round up, however. And we're going to need a 6-footer for that little piece there because from neither direction are we ending up exactly on that spot. So we need a 6-foot piece to put there. So we need a 6-foot joist. We need one of those for our 16-footers. For that piece there, our number of joists is 12 over 16 times 18. We need one at this end up here. We do not need one at this end down here. So we're just going to leave it as it is. Add 0 to it. The 12/16, we are going to round up though. 12 divided by 16 times 18 should be 13.5. We round that up to 14. So we need 14 of the 16-footers. But we're going to need more of them because this is 16-footers over here on a 56-foot run, and we do need them at both ends. So the number of joists for that, 12 over 16 times a 56-foot run, and since we need them on both ends, we're adding 1. So that's 42 plus 1 is 43. So we need a total. 14 plus 43 is 57 16-foot joists. I didn't figure it out on the last one, but for rim joist, the rim joist is just going to be at the ends, here, 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 and here. That's going to be 56 feet on both ends. So that's just going to be 112 feet of rim joist. And our final thing, bridging material. We actually will come back and do the flooring in just a second, but the last thing that you were assigned is bridging. You have 56 feet here, 18 feet here, and 20 feet here. These only have a 10-foot span, so you do not need bridging there. We have 56 feet plus 18 feet plus 20 feet, which is what, 74, 94 feet. So the bridging is 94 feet of run times 3 feet, which is 282 feet of bridging material. Remember, that's usually 1x3s or 1x4s that are used for bridging. I'm going to give you guys a couple of minutes. Figure out how many 4-foot by 8-foot sheets we would need for flooring. If you don't have your packet in front of you, I'll put this back up so you have the dimensions. I'll erase some of my mess. There you go. We'll talk about it in about a minute.
Recording is on.
Okay, so we need to find the area of this. So I'm going to cut it into 3 sections like this. So section 1 is 32 by 18. Thirty-two times 18 is 576 square feet. Section 2 is 26 feet by 18. Twenty-six times 18 is 468 square feet. And section 3 is 30 feet by 20 feet. So 600 square feet. So if we add that up, so we're getting 1,644 square feet of area. We divide that by 32 square feet per sheet. 51.375, so it's going to round up to 52 sheets. Now again, personally, I would have modularized this floor plan to figure out how many sheets, but we come up with the 52 sheets, and most likely we would add a waste factor. Now again, what I was looking for here was the 52 sheets, so if you came up with that, you did perfect. But for a house like this, looking at it, 26 feet across there, that's not modular. This is not modular. I would probably add probably no more than 10% for waste. So to add 10% for waste, all I'm going to do is multiply by 1.10. 1.10 is 110% is a decimal, as a rate. So that ends up being 57.2, which I'll round up to 58 sheets. Now again, the answer you were looking for was the 52. That's if we decide we want to now add a percentage for waste. That would be 10% for waste. Any questions on finding the girders, sills, joists, bridging, or floor sheeting? So for the rest of our first hour today, I want to talk about exterior wall studs. Find exterior wall studs. Let's just look at a basic floor plan here. So this house here is going to be 32 feet by 42 feet. Our formula, the number of studs, is once again equal to 12 over our on-center spacing times, this time it's times the perimeter of the house, plus a factor A again. A is a little more complex this time, though. Well, let's find the basic portion of this. If we assume we're doing 16-inch centers, 16-inch spacing for our studs, the perimeter, if I do 32 plus 42 plus 32 plus 42, what is that, 74, so 148 feet. So it's 12 over 16 times 148. Gives us 111 studs. So that is without adding our factor A. We need to talk about what is A. Well, A has a lot of factors into it. It is +2 for each corner. Why is it +2 for each corner? We know that if we're doing a wall, let's say this 32-foot wall here, that we need to add 1 for the beginning because, well, when we do our division, it just gives us the studs here. It gives us the one at the end, but not the one at the beginning. So that's where one of those comes from, is the one at the beginning of the wall. The second one comes from, if I look at that corner up here and the way it has to be framed. I'm actually going to mock it up a little bit all the way down. We're assuming our corners are lapped something like this. So we'll have, the first stud right here. At 16 inches, there'll be a stud here and all the way down. And then, of course, one at the end of that framing, and then the next wall starts. But you see what happens here. The first stud of this wall on top is going to be there, and they'll be spaced going this way. This works great for the exterior sheeting. Put your OSB on the outside, and it works out perfectly. It should come out right on one of the studs. On this side over here, you'll have to cut a little bit, but if you have a modular house, you change your stud spacing to get it back to modular, or you start from the end that the wall framing starts from. But either way, it works going in this direction. Where it doesn't work so well is on the interior. Your sheetrock works just fine on this wall, but on this wall here, there is nothing to nail this end of the sheetrock to. There's nothing to fasten that to. So the second stud comes from, you usually put a stud right here, an extra stud in there so that you have something to fasten sheetrock to. You have to be very careful with that because I've seen people do it a lot. They put that stud in there, they put the walls up, they forget to pack insulation into this corner here, and they end up not being able to insulate those corners. I've seen people sitting there drilling so they can try to shoot spray foam in there or something to fill them. It never gets them filled real well that way. So make sure that when you put that stud in, you leave enough gap here that you can get insulation into that corner. You're allowed to actually allow sheetrock, I believe, is up to 6 inches if it's 3/8 sheetrock, and up to 8 inches if it's 1/2 inch sheetrock. Don't quote me on those standards. Those are old code standards, and they've probably updated them since then. But I would leave an inch gap here from here to here just so you got room to put insulation in that corner. But you do need that second extra stud there. So that's what the 2 studs for each corner are for. +1 for each non-modular wall. Non-modular wall length. Now, modular is divisible by 4. The 32 is modular. This would also be 32. That would be modular. 42 is not modular. It's not divisible by 4. So we have 2 walls that are not modular. So I'm going to add 2 because there's 2 walls that are non-modular. I should go back here. I'm going to add 8 for that top one because there are 4 corners, and 2 for each corner would be 8. We also add 1 for each intersecting interior partition. Now, a partition is mainly just a wall. So what that's saying is if we have a rough layout here, we have 1, 2, 3, 4, 5 intersecting interior walls. So intersecting the outside wall, that would be plus 5 more studs. Why do we add for those? Well, again, it's that sheetrock. Let me put my studs in down here. Leave a little more space here for this to easier to see. Let's say my interior wall comes in right here. Well, there's an interior wall stud right there that handles the sheetrock on this wall and on this wall. But the sheetrock on the exterior wall here is not going to match up. We need two things. We need something to anchor the sheetrock to on the exterior wall coming from both directions. We also need something to securely anchor this interior wall to. One of the accepted practices, since that's going to be a 2x4 interior wall, is to put an extra 2x6 stud in that exterior wall like that. So now you can anchor this wall, this interior wall, into that 2x6 stud, and you've got an inch on each side to anchor sheetrock to. So that's why it's an extra 1 for every intersecting interior partition. Now this is something that depends on municipality and building inspector. Some building inspectors don't like that, and it's left up to their opinion in many cases. The reason they don't like it is because it does compress your insulation in the wall. And it can, so that insulation that's compressed by that 1.5 inches is slightly less effective there. If you're using spray foam, it doesn't matter because you're not filling up a whole 5.5-inch wall cavity anyway. You still have 4 inches there, which is more than what you would fill with spray foam. But like I said, some inspectors are not real keen on putting that extra stud in there. We are going to add it here just because it's good to practice. We're going to add 2 for each door or window. So let's come up here. I need to give you some doors and windows. Let's say I've got a window here, here. We'll do windows like that, and we'll do a door here and a door here. So we have 1, 2, 3, 4, 5, 6 windows and 1, 2 doors. So it's a total of 8 times 2. That's going to be 16 for my doors and windows. So that means we're going to add a total of, what is that, 31? That's A. So we'd add 31 to my 111. Give us 142 studs for this, for the exterior walls of this floor plan. Any questions? Okay. Well, unfortunately, the packet does not give a good second example. They have one example that they give, and they don't give you a good floor plan for a second one. Your homework here, I'm just going to sketch out a quick floor plan. I'm actually going to sketch out 2. There's my interior walls in gray. I'll do my windows. Green. And my doors in blue. That's problem number one. Just get it sketched out in your notes. Problem number two. It's gonna look like this one. Put in my windows. And my doors. So let's get those sketched out. I'll give you the last 5 minutes to get started on those here. We'll go over one of them quickly at the beginning of our second hour, but I'm actually going to stop the recording here for you so you guys can work on those, and we will come back and we will start lecturing again at 1:30. So I'll give you 5 minutes to get started on these and then take a 10-minute break if you'd like.